Hello everyone, welcome back to this Beckhoff AX8000 motion control series video. In this video, we will discuss the topic number 10, how can we implement the NC torque control using TwinCAT 3 and the AX8000 motion control system. And the Beckhoff NC torque control just released this year, 2021. Torque control this function block that can switch your axis and the motion control mode into the torque control mode. So if you are using this function block, you can set the torque and also you can set the velocity limitation high and low. Regarding this velocity limitation, as we know, one typical torque control example, that is the rewind control. As we know, if the web got broken, the rewind will lose the load and the rewind speed will keep high because the torque value is still the same as before. Your rewind velocity will be very high, so we need to limit the velocity in a certain range. In terms of this torque setting, basically the torque set point would come from your web tension. The web tension could come from your taper curve or some tension set point. So you can keep the certain torque on your drive and your web tension can be kept from this drive torque. Maybe you will ask, why not use the velocity control and the tension PID, adjusting the velocity? It's still fine, but as we know, if we are going to use the velocity control, the rewind diameter need to be measured accurately. But some cases, if the diameter cannot be measured accurately, for example, if the web material that is transparent, so the laser sensor cannot measure the transparent material accurately, or some cases the tension sensor is not available. So in those cases, the torque control may be a proper way to control the rewind. And another feature for using this torque control is a very good feature from the Beckhoff is that we can switch the position control, velocity control, and this torque control back and forth smoothly. So for example, if the product for here, for the rewind, this rewind, we need to run 2 meter or 3 meter relative move, then the rewind will stop. And after a certain time, the rewind will rewind 2 or 3 meters. That 2 or 3 meters that actually come from the product length. So if you rewind, you need to do the velocity or the positioning control, and after that you switch to the torque control mode, so you need to switch back and forth, then you can use this MC torque control. This MC torque control can switch from your positioning or velocity control, go to the torque control. Alright, let's shift to the TwinCAT 3 and let me show how can we implement the torque control. So far, from the Beckhoff information system, we cannot find any detailed description for this torque control. This may be my key motivation to show how can we implement this torque control. So you can follow my procedure and implement this torque control and try by yourself. Alright, let's shift to the TwinCAT project. To implement the MC torque control, we have to use the drive manager and go to the advanced. At here, we need to do some important configuration at first. In this case, I will use the channel A motion system. Okay, firstly, let's go to the slot setting. Go to the slot setting and we check this box. I know what I do. And go to the velocity control slot. Select the velocity control 2. Make sure we select this. And then let's go to the process data. At this channel A here, virtual operation mode 0. Let's select the 10 CST mode, torque mode. Okay, make sure after we select everything and configure everything, we need to download active hardware configuration. Okay, let's go to the output here. This PDO, let's search 6060 first. This is channel A, most of the operation. And then search the 6071. Okay, make sure we transfer from the left to right for this target torque false. Okay, for channel A, its number is 6071. For the channel B, this number will not be the same, so you can search target torque false. And then let's search the 60C8. We can search the low velocity limitation value. This is used to limit the velocity. This is low velocity limit. And again, for the channel B, this number will not be the same. So you can search low velocity limit. And next, let's search 60C9 for the channel A. So we will search high velocity limit. Okay. And then as this input here, we need to search the 6061, transfer the 6061, this channel A modes of operation display from the left to the right side. And then search 6077, this torque force actual value. Okay, for the channel A, that's the 6077, torque force actual value. And then next, let's go to the parameter list and search 60C8 for the channel A. That's the torque limitation operation code. So we switch to the number 1. Torque might be reduced to 0. Okay. For the channel B, you can search the torque limitation operation code. Switch to the mode to 1. And after this switch, don't forget, click this download. We will download this setting because we are at the parameter list. Okay, till here, we basically finish all the settings for the torque control. And then we need to switch to the NC axis. And we need to set one setting, one configuration at the NC axis configuration area. Because I'm using the channel A, I will go to the NC axis, the axis 1. We can see this link to I/O. It connects to the channel A. And then let's go to the time compensation. So switch this setting to on with velocity. Download. This setting is used to smooth switching from the positioning mode into the torque mode. So the time compensation has to be enabled. So we need to switch this to on. Okay? Okay, till here we finish all the configuration. And we can log out. And we can declare the instant of the MC torque control. Okay, we can use the input assistant and we can search MC torque control. Under the velocity here, we can call that instant. We can call that instant. Okay, we can use the input assistant. Go to the instant call. We can call this MC torque control instant. Okay. We can use the same access name. Okay. And then we can declare some other variables that are used to connect to this instant function block. Okay. First one, that's the torque execute command. And next, that's the torque setting. And this torque setting is unit is 100%. If we need to set 50%, we can set 50 here. If we need to set 100, we can set 100 for this torque setting. This is just an example. Later, I will comment this line out. Okay, this is the one variable, so we can change this variable on the fly. But every time we change, we need to trigger. But there's one issue for only one instant here. If we need to change the torque setting on the fly, for example, the first time we set 50, we trigger the 50 implement into the system. And now we need to reduce this torque setting to 30%. If we trigger again, that 30, the new value, will now be updated for this function block. I will show this case. If we switch the torque mode and the velocity mode back and forth, every time we switch back, okay, we set a new value and a trigger, which is fine. However, if we only use the torque mode, and if we need to update the different set point for this torque setting here, we need to use 2 instant torque control. I will show this case after. Just to mention here at first. So keep in mind, if you need to update this torque setting, you need to 2 torque control here. This is similar idea as the velocity function block, MC move velocity. And next things, we need to assign one variable as this options. Okay, this options need to use one st structure. This options need to use one structure from this UDT. To check out this UDT, the st structure. So go to the input assistant, we can search MC torque. And then we can find for this options here, which UDT is using. ST torque control options. Okay, it's using this. And here we can declare one variable. This variable is datatype name is st underscore torque control options. We declare this variable here. And we can copy and paste here options. There's one feature we need to use this options here. That is named enable manual torque start value. Okay, we will use the st torque options dot enable manual torque start value. We can set to true. And then that manual torque start value that come from our actual torque. Our actual torque come from our axis, so we can call this axis dot nc to plc dot actual torque. Okay, this can do a smooth switching. Okay, and then let's set this velocity limitation. So we can set 1000. Here the unit, that's a degree per second. I can show how this runs, how this performance after. For this torque ramp, its unit, that's the percent per second. So we can set the torque increasing the acceleration. If we set 100% at here, that means the torque will directly go to the set point in 1 second. If we set it lower, we can see the torque will ramp up slowly. And now we finish everything. Let's build the solution. And very importantly, we need to activate the hardware configuration because we did a lot of hardware configuration. Okay, we download the hardware configuration, active configuration. Okay, we download everything, and now we can log in the program so we can implement this torque control program. And let's check this 6060, this mode of operation. Currently, we power on the motor, and by default, our motion is at the CSP, the positioning mode. Okay, so using the MC torque control, we can switch between the positioning mode and the torque control mode back and forth. So by default, the drive is using CSP mode. Let's power up the motor. Firstly, let's enable the safety. Okay, STO safety enable. Now it's on. And now let's enable the motor. Okay, we power on the motor. And then let's go to the MC velocity. Let's firstly run the velocity control. Okay, let's start up this recording. So now we can see the motor is running at 1800 velocity. That's a degree per second. And torque, currently, that's the 1.6. And we are currently running the MC velocity. And now we can switch to the MC torque. Okay, let's turn off this MC velocity. It's still running the MC velocity. Okay, and now we are going to trigger this MC torque control. We can set the torque set point to 1. And this velocity limitation, that is 3500. Okay, and once we trigger, and let's see the actual torque value, what it will be. Okay, we trigger. And now let's shift back to the curve, and we can see here. So after we trigger the MC torque control, because we are going to control 1%, so this torque value changed from the 1.6 to 1%. And the speed decreased because this torque is too small. Okay, the torque is too small. And now we can increase this torque value, set to 2. And we can trigger. But we can see after we trigger this 2, the new set point won't be delivered into the system. This is what I said. Using one MC torque control, if you update this set point, if you trigger again, this new set point won't be delivered into the system. There will be two ways to update this new setting. One way, we can switch to another control mode, for example, velocity or the positioning control, and then we switch back. Or we can set up two instant function blocks, MC torque control 1 and MC torque control 2. Using two instant here, we can switch back and forth. Using one is not enough. Okay, let me show the first method. We will trigger the MC velocity at first and then switch back. So this two new set point will be transferred to the system. We can use the MC velocity, trigger the MC velocity at first. Okay, quickly switch back and forth. And we trigger the velocity. Now is running 1800 and running the 1.6 actual torque. Okay. And now let's retrigger this MC torque control. So we set 2%. Okay, we trigger. This time will be update. Okay, we can see the torque value are set to 2. This 2 delivered into the system. And now the speed will be very high, reach to the high limitation, 3500. Okay, if we hold the shaft, velocity decrease, but the torque still at 2. Okay, because we are going to control the torque at 2%. Okay, the speed limitation is just a high limitation, but the actual speed depends on the actual load. But the torque, the highest torque will be 2%. Okay, because the set point is 2 here. Okay, we trigger the velocity again, so we can see the difference. So now switch to the velocity again. So the speed go from the 3500 back to the 1800. Okay, now we can set a new torque value. For example, if I set higher, set 5%, and let's trigger this new torque setting. Trigger. Okay, we can see here. This is interesting now. So as we can see, the speed reached to the highest limitation here, 3500. We set 5%, but actually the system does not need the 5% because now the motor is doing the free run. So the motor just delivers the torque, the actual load it needs is just a 1.6. Our set point is 5% because now it's a free run. If we apply the certain load on this motor, we will see the drive will increase the torque for the motor, but the highest torque it can reach, that's the 5% according to our setting. Okay, I can apply a certain load. We can see the highest value delivered from the motor is just 5%, and speed will be decreased. This is the MC torque control mode with the 5% torque value setting. So using this curve, we can imagine if we are using this motor running as a rewind, the rewinder. So the highest torque from the motor will be only 5%. The motor won't break the web, and its velocity can be limited in a certain range. This is the typical curve while we are using the torque control mode doing the rewind, especially for the case the diameter cannot be measured accurately, and the velocity will be dynamic according to the actual load. Alright, now let's shift to the topic, how can we use two instant function block to update the torque setting. Okay, if we switch to 3, currently I'm still using one instant function block so far. If I use the same function block, instant function block, so the 3 won't be updated. Apply the same load, so we can see it's still running the 5%. And to implement this update, this set point update, we have to use two instant function block here. We can use the existing one as 1, and we need to create a second one, FB MC torque control 2. Okay, now let's log out and let me program the second instant function block. Okay, I will firstly refactor in this existing instant function block, rename it to 1. Okay, and then I will declare the second one. The second instant function block. Okay, and I will declare the second trigger. Okay, declare two triggers. And for the torque setting, so we can set the torque setting 1 and 2. And then we need to call the second instant function block, the MC torque 2. I will copy the first one, paste, and change to 2. Okay, we have two instant function block call. And for the torque control 2, we can change the torque set point to torque setting 2 here. Okay, we can log in. All right, now for the torque control 1, we can set 3. And for the second torque control, we can set 5. Okay, we are using two instant function block here. We can trigger the first one. The first instant function block, we set the torque set point, that is 3%. So we apply the load and we can see the highest torque. The highest torque is held at 3%. Okay, we are using the number 1 torque control instant function block. And now let's go to trigger the second torque control. Okay, its set point is 5%. Okay, we trigger. And now we can go to the curve and we can apply the load. We can see the highest torque is held at 5%. Okay, so using this two function block, we can switch back and forth. If we switch back to the 3%, we can trigger again. And now the highest torque it can deliver, that's 3%. You can see it switched back to 3%. Let's shift from the 3 to 5 again. Okay, this is demonstration to show we switch back and forth, switch the different torque setting. So now it should run 5%. Okay, it's running 5%. So as we can see, if we are using the two torque control, the instant function block here, or using the different set point for different function block, they can switch back and forth. So the new set point can be updated, can deliver to the system. So this is the torque control function block. And now if we switch to the velocity again, so the system can smoothly switch to the velocity. So we can see the speed go back to 1800 and the torque will go back to the actual torque 1.6 like a regular run. So switching this mode can back and forth smoothly. Alright, this is the MC torque control. When we set a set point for the MC torque control command, so the highest torque from the motor that will be held under the 5. And meantime, the velocity will adaptive. Okay, this is the typical case, especially when we are using the rewind control. This highest torque set point will depend on the tension, the highest tension from the web. And the speed can be adaptive according to the mainline speed. So we can set a torque set point and allow the system just to do a rewind and its actual speed can adaptively. Okay, this is the MC torque control from the Beckhoff NC axis. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.